Hello, and welcome to the next in my series of Linux lectures. Today we're going to think about programming in C, and we'll start by writing for ourselves a simple C program using the Vim text editor. Here we are in insert mode, and I'm going to create myself a main method. Inside this method I'm just going to print hello world. \n to indicate the new line, semicolon at the end, and we'll return 0 from our main method. There's our program. Right, we're going to compile this program, and we're going to use the Clang compiler. First of all, we're just going to check that the program is correct. And you see here that we receive a warning message. Warning. The warning message is because we're using the printf function to print the standard output, but we haven't told the system, the compiler at least, where to get the printf function from. We need to use this header file here called standardio.h. Let's try that. Vim hello.c. I'm going to press I to insert and hash include angle bracket standardio.h, which should provide a definition for the printf function. Now I'm going to press the up arrow to go back to the previous command, clang hello.c, f syntax only. If you don't get any errors, that means the program is probably okay. Let's just run clang hello.c. and I want my output file to be called hello. There it is there. Now to run this program I say ./hello. / indicates the current directory where hello resides. I run it and it says hello world. Great. We could change this program slightly. Oh dear, I've just opened the binary file. I didn't mean to do that. Let's quit. Okay, and let's try again with hello.c, which opens the text file. That's what we want. Let's change in main to have some arguments. argc is the arg count. argv is the vector of arguments, which are strings. That's a character array, effectively. Sorry, it's a jar star star, which is, in Java speak, it's an array of strings. Okay. Instead of saying hello world, I'm going to say hello %s, which is a string, and the string is argv1, which is the first argument. Okay, let's try this now. Excuse the passing helicopter. So we're going to say clang hello.c, we'll call this one hello2, we've changed it slightly, /hello2. Oh, it runs hello, and then it produces null. So on the strings, we haven't given an argument. Let's give it an argument. Let's say hello, Jeremy. Oh, and spell it right as well. Sorry, hello, Jeremy. There we go. In this next example, I'm going to show how to use a Makefile to build your C program automatically. First, I'm going to go in and change the C program we wrote. I'm going to delete a few lines, and I'm going to include another header file here, which I'll call constant.h. Notice I'm using quotes for this header to say that it's a user-defined header in the current directory rather than the standard library header that has angle brackets around it. Okay. Then I'm going to change the string which is going to be printed to be my constant string. Now, if I compile this straight away, it's going to complain that it can't find the header. Constant.h file not found. So I need to add a constant.h file, constant.h. And inside here, I'm going to create myself a variable called constant string. string, which will have the value Linux students. There we go. Now I should be able to run my program, compile my program, clang-hello.c, and run it. I need to say clang-hello.c-o, hello, ls, there it is, hello. So I can say /hello, and hopefully it's going to say hello Linux students. Yay, it does. Right, and if I want to make it say something else, I just need to change constant.h, $, escape A, and now I can say hello everyone. There we go. Save that. And again, I'm going to run clang hello.c-o hello. Hello. It should say hello everyone. It does. Great. Okay. Now, what I want to do is write for myself a Makefile which allows me to automate the build process, the compilation of hello.c. I'm going to create a new file called Makefile. I'm going to say I'm trying to build hello, that's the target, and hello depends on hello.c and header file constants.h. To build hello, I use the command clang hello.c-o hello. Right, I'm going to quit after saving, and now I should be able to type make. It says the program is up to date. Let's change constant.h. And now I say make, and it rebuilds it. I run the program, hello, hello everyone else. If I say make again, it doesn't rerun the program, it says the program's up to date. Now, the reason why make knows the program's up to date is because it can compare the timestamps. I do an ls-l, and I can see that hello.c was last modified at 12 minutes past 5. I can see that constant.h was last modified at 5:15, and hello was created at 5:15. So, what time is it now? Still 5:15, it's nearly 17:15. Okay, suppose I go in and change constant.h. Okay, now I'm going to change it to say hello again. W to save, Q to quit. Now I'll say ls-l, and we can see constant.h has been modified since hello, the executable file, has been created. So when I say make, it will remake it. And then I can run it again, and there we go. So make allows us to type fewer characters in our compilation instead of having to type, where's it gone? Pressing the up arrow to go back through my history. Instead of having to type clang hello.c-o hello, instead I just type make. And also, it doesn't actually do the compilation unless it needs to when one of the files changes, one of the dependent files. Suppose I change hello.c, say printf make, and it will run it again. Sorry, compile it again, then I can run it. Okay, then I do it again, make. It's up to date, doesn't need to be made. Let's have a look at this folder now. I've got my executable, hello. I've got my Makefile, which specifies how to build hello. My source code file is hello.c, constants.h. This is the previous executable, I don't need that one anymore. Right, going back to my Makefile, and I'm going to add an extra target called clean. Clean is going to rm-f hello, which will get rid of the executable file. Now I'm going to say make clean. And look, the executable disappeared, so I need to make it again before I can run it. Okay, make clean, and that deletes the executable. And you can imagine for a compilation that generates lots of files, you would use make clean to get rid of all those intermediate files. We'll see that tomorrow when we look at the LaTeX program. Good. One more Makefile. Sorry, quit that. One more Makefile feature is the possibility of using variables. Let's say C_compiler equals clang, and then here we can say $cc, and that will run the Makefile for us. Okay. I should tell you that there is also another C compiler that's commonly used, which is called GCC. This is the GNU C compiler, as opposed to the LLVM compiler, and I can use that as well. Make clean, make, and the program should have the same effect. It does. It's compiled differently, so the code, the object code might be different, but it executes the same C program and should have the same results.